Welcome to Portfolio Theory Video 3. I'm looking at the spreadsheet decomp of VAR 3 stock, and here I'm illustrating for you what decomposition of portfolio return variance really means. So in this case we have 3 stocks, X, Y, and Z, and we have 20, 30, and 50% of our portfolio invested in each of these stocks. And these 6 rows are showing the returns earned in a given period for X, Y, and Z, HPRs. Okay? For example, in the first period, X earned 3%, Y 12%, Z 11%. Over here under P for portfolio, what I'm showing is if we had a portfolio comprised of 20% X, 30% Y, 50% Z, what our portfolio return would have been. That 9.7 is simply 0.2 times 3% plus 0.3 times 12% plus 0.5 times 11%. That gives you 9.7%. Portfolio return is a simple weighted average of the returns on the stocks that constitute the portfolio. However, at this point in time, we no longer have 20, 30, and 50% of our portfolio in X, Y, and Z, because if they're not increasing at the same rate, these weights will change. So theoretically, we are assuming that we have to rebalance our portfolio weightings back to 20, 30, and 50% respectively every time we calculate a return at the end of every period, whatever that period is, 1 day, 1 week, 1 hour, 1 month, 1 year, whatever. Keep that in mind. When we assume that we rebalance, then we can do analysis in which the weights are constants, and that's helpful for us to see. This is not saying that rebalancing portfolios is a good idea or is a bad idea. It's just the requisite assumption for our analysis to come. Okay, so here we have the returns of X for each of the 3 periods, Y and Z, and then the portfolio with these rebalanced weightings. Now, we can calculate the variance of all the numbers that you see here in the dark and blue, and here, all the numbers you see in the dark and blue. Here's the variance of the X's, here's the variance of the Y's, and here's the variance of the Z's. And of course, we can calculate the variance of the portfolio values that you see in the dark and blue, and it ends up being 222.78667% squared. And we observed that. But the first thing I want you to know is this number, 222.78667, is the same number that appears here, 222.78667. And we can see that the formula in this cell is what we'll come to know as the decomposition of portfolio return variance formula for a 3-stock portfolio. In the MPT1 spreadsheet, on the 5th page in that PDF, we looked at the variance of a weighted sum. We can consider that example to represent a 2-stock portfolio with weights in X and Y respectively of A and B, such that A and B sum to 1. Here is a more complicated case where we have 3 stocks. But if you look at this, you can see what we have here is, with my notation, the weight in X squared times the variance of X, that's C10, plus the weight in Y squared times the variance of Y, plus the weight in Z squared times the variance of Z. Now, important, plus 2 times the weight in X times the weight in Y times the covariance of the returns of X and Y, plus 2 times the weight in X times the weight in Z times D11, which is the covariance of the returns of X and Z, and then plus 2 times the weight in Y times the weight in Z times E11, which is the covariance of the returns of Y and Z. And so what we see there in an Excel formula format is the decomposition of portfolio return variance formula for a 3-stock portfolio. And I think this spreadsheet makes clear in an easily digestible manner that we could just calculate the variance of that column of numbers, quite simply, and get this value. And we could also get the same value by using this decomposition of portfolio return variance formula for a 3-stock portfolio. That formula changes for different size portfolios, as we will see in the lectures to come. But this, I think, is a nice way of seeing what we're doing. So, of course, we could calculate the variance of the portfolio's return like this. And the variance of a portfolio's return is the appropriate measure of the risk of a portfolio, the relevant risk that we should be using in our analyses, many would argue. But when we use the decomposition of portfolio return variance formula, it helps us see the importance of the variance terms and, even more importantly, the covariances between and among the securities that constitute the portfolio. And that's enough for this video. Thanks for watching.